Hello and welcome to another episode of the Fully Charged Show podcast. This week's episode, just amazing. This is an amazing story. So Gerard Barron founded a company called DeepGreen, and well, I don't want to tell you anything about it because he's going to explain it much better than I possibly could. It is just the most fascinating conversation, really, really intriguing, challenging, fascinating, historic, extraordinary. Anyway, before we start that, let me just quickly mention our wonderful sponsor, Ripple Energy, because Ripple Energy are in the process, as I speak, of building the UK's first consumer-owned wind farm. This is at Graig Fatha in South Wales, and as you can tell, I've got a Welsh name, but an absolute inability to pronounce the Welsh properly. Graig Fatha is a wind farm in Wales, and it's currently open for ownership, so you can actually buy part of a wind farm, and your share, you then get your share of the electricity it generates supplied to your home. This is a totally new source of green energy, and this wasn't possible before Ripple made it happen. So you can power your car or your home with electricity from your tiny bit of your very own wind farm. But Ripple have a much bigger impact than that on green tariffs. You will actually help to get brand new wind farms built. And it's important to point out at this moment in time that the legislation which has restricted the development of onshore wind farms in the last, I guess, 10 years has been relaxed. And there's going to be a lot more development in that area because we really need it. Scotland, they don't need as much as we do. In fact, they produce so much electricity, England buys it from them. Very important point, that. But anyway, so Ripple have got a different way of thinking about that. So they've partnered with really amazing energy companies, Octopus Energy, which we heard about last week, Co-op Energy. And if you are one of their customers, you don't need to do anything. You can sign up to Ripple Energy. You can buy some shares in a wind farm, and that will automatically reduce your bills. And it works particularly well with specialist EV tariffs, which we talked about last week in great detail, like Agile and Go tariffs, all those things. And Ripple estimates you can save up to 25% per year on your electricity bill, which is not bad. That's like less money that you're spending. So it's and the other thing is, because there's a lot of people, I've spoken to many people about this, who would love to have rooftop solar, but they live in an apartment or they live in a rented accommodation and they can't do it. Well, this is a way of you buying a share in renewable energy that you can take with you. You don't have to leave it on your roof when you move. You own it anyway. It doesn't matter where you live. You can live anywhere and still be a part of that. So it cost about £1,800 to buy a chunk of a wind farm. So Ripple, really innovative company. It's really worth going to have a look at what they're doing. RippleEnergy.com. www.rippleenergy.com. Anyway, let's get back to the podcast. For a start, Gerard, thank you so much for taking the time to come on the Fully Charged Show podcast. Because this is such a thrill for me, because I hear about things like the project you're working on. I go, oh my God, that's amazing. I wonder how that works. And, and then I've now got the opportunity of talking to you, and I really appreciate it. It's fascinating. So I had heard about what you were doing whenever you would have started it, or there would have been a press launch a while ago. But it's such an intriguing area, and it's so potentially contentious because of the way the human race, charges around the world, rapaciously ripping stuff out of the ground. And we've been doing it for hundreds of years, and we're realizing there may be a downside finally, after sort of nearly 200 years of the Industrial Revolution. But I have no idea what the impact of what you're doing is, but it feels like it's sort of potentially not disastrous. I'll go that far, and I'm just going to say what I know about the deep ocean. There's not a lot of fish there. I don't know. There's not a lot of life from when I've seen footage of people going down really deep, they say it's like a desert, but they do see little blobby things swimming about, but it's not like a shoal of cod in the North Sea. It's pretty remote. But So tell me what about that. So what gave you the initial idea? How did you know because the name of the nodules, polymetallic nodules. Oh,
Yes, yes.
oh, there is one. Oh
There
my
is one
God.
there. Yeah.
That's quite a
And,
big chunk as well.
well,
Wow.
they come in different sizes, and
Right.
the size of it will tell you the age.
Right.
And they literally just look like this sitting on the ocean floor. And
Wow.
so your assumption is absolutely correct, and that is that it's the abyssal zone. So it's like the most common area on the planet.
Right.
It's like a massive desert down there. It just happens to be on the bottom of the ocean. And, most life is in the top 200 meters of the
Yeah.
ocean surface, and we're 4,000 meters and below. And
Wow.
so
Wow.
there's no food down there, right?
No.
That's the problem. There's no food and there's no energy, which means that the organisms that we're doing our studies on, okay, there are some that live on top of the nodules. And
Right.
so what this environmental studies are saying is, well, what happens to them? It's like, well, firstly, we don't take all the nodules, so they can rehabitat. But also, there are big areas that have been put aside for preservation, big areas that will never have nodules removed from them. But the organisms that are most abundant live in the mud, and they will not be seriously impacted. They'll have a bit of a dizzying ride because if we drive over them, they'll get shaken up, but we won't. It's unlikely we'll kill them, that's for sure.
Yeah.
And so, and this is one of the challenges that when you think about impacts, of course, we spend a lot of energy looking at the impacts of collecting the metals from these nodules compared to the known impacts of what we do on land today. And of course, the trouble is, we've all focused on fossil fuels, and we know that the fossil fuel industry has, deposited lots of CO2 into our atmosphere, contributed to global warming, rising sea levels, lots of these externalities. But we haven't focused on the big old mining industry because it's out of sight, it's out of mind. But as we start to ramp that up, those impacts are going to be enormous. So a different resource, but the same dirty game. And so, impacts is what we need to get to, right? We need to have grown up conversations about, why it's a better choice to be collecting one virgin ore over another virgin ore. And you can only do that if you do a full life cycle analysis from cradle to gate of not just biodiversity, not just CO2 emissions, not just water usage, not just deforestation. You've got to look at all of those factors as they come together. So, so it's a very, very interesting time because, of course, we're on the doorstep of the final code being adopted. And so that has our opponents getting very agitated because they don't get a seat at the table. And so they're a little bit annoyed about that because this is decided by the nations of the world, the International Seabed Authority and its member states are sovereigns, countries. And so like the United Nations is run by countries, it's the same thing.
Yes. Right. Okay. So you've got to explain a bit of that because that is news to me. The code. So they are creating a code which will regulate what you can and can't do on the seabed. Is that? Am I getting that roughly right?
So if we cast our mind back to the 1970s, they started to collect these nodules. So they discovered them in the 1870s. Right?
Wow.
1870s. The HMS Challenger, funded by the Royal Society here in London.
Wow.
Paid for them to go and explore what was on the bottom of the ocean.
Yeah.
And the steam piston had been developed, and so they threw a basket or a dredge off the back, and they sailed around the world. And they came up with these nodules in a variety of locations. But there's only one place where they're of particular interest, and that's this area known as the CCZ, Clarion-Clipperton Zone, because they precipitate the metals that are in the ocean water or that are in the ocean sediment. Now, once upon a time, the Rockies and the Andes were covered in nickel and copper. And so as all of those metals eroded into the rivers and the oceans, they deposited in the Pacific Ocean. And so the feedstock here was very rich, whereas the nodules that are found in the North Sea, they're not worth picking up. They're
Right.
just full of iron and some manganese, and they're not valuable. Whereas
Right.
that is an electric vehicle battery in a rock.
Right, that is extraordinary. But that history then, so the geological history, because that's, I mean, obviously one of the main questions I've got to ask you is why are they there and where do they come from?
Yeah.
But that explains it. So it is, so when those mountains were formed, they were very heavily made of the metals that you find in those nodules.
Yes.
But
Yeah.
that is literally particles of that have washed off, gone
Right.
down the rivers, gone into the sea,
Yes.
collected themselves in the sea, gone right down to the bottom, been squashed. I mean, the pressure down there, that's another thing I want to ask, is probably we'd find fairly difficult to deal with as frail humans. But that's extraordinary then. So so do you know roughly how old that nodule is that you've got?
The one I'm holding now would be 7 to 8 million years old.
Right.
Yeah.
Wow.
And of course, as we know, the entire planet was covered in water or ice once upon a time.
Yeah.
And so, whereas most of our land-based ore bodies are sulfides, so they form through volcanogenic activity,
right.
or they are laterites, so they form through very wet leaching over millions of years.
Right.
Whereas these grow, they literally grow like a pearl grows, so they precipitate all of those metals around them. And that's what makes them such a delight to handle when we turn them into battery materials, because we kind of, I don't want to oversimplify it, but we kind of reverse the process. And they don't have all of those deleterious elements like arsenic and mercury, which terrestrial deposits have. And that's why those terrestrial deposits have to have these nasty tailings dams, which is where all of those elements end up, and you have to keep those tailings dams forever.
Right.
And unfortunately, they have a habit of bursting and wiping out communities and human lives. And so, the list of advantages in collecting these over continuing to do what is happening now on land is endless, in my opinion.
Right.
But of course, you're right. Everything has an impact.
Yeah.
We will have an impact by collecting these nodules.
Yeah.
And so what our ocean research science program is all about is understanding those impacts and then being able to say, well, with those set of impacts versus those set of impacts, this is the right way to go.
Right. Yeah.
We should be doing this.
It's the minimal impact. But then, so in terms of quantity of them, then, is that, is it enough to build 5 luxury batteries for a Porsche Taycan, or is it enough to build 500, a million cheap Nissans? I don't know. I mean, there is enough. There's a lot of it there.
Yes, there is. There's enough to electrify the entire fleet three times over.
Oh, right. Okay.
We have enough on our ground, on our license areas, and we control 3 blocks in this area, and we've defined the resource on 2 of them, and on those 2 blocks we have enough battery materials to build 255 million 75 kilowatt batteries.
Right.
So
quite a lot.
Yeah.
But that's so God, it's just so extraordinary. Because I want to go back then, I need to understand that a little clearer. The materials that are in those nodules are the materials that you would want to make a battery are easier to extract from those nodules than if you've dug up a load of ore in Chile or wherever, Australia.
Yes.
So the actual industrial intensity of extracting the specific materials you want is reduced.
I mean, it's not very conducive to a podcast, but I have a fabulous presentation that shows you these side-by-side impacts.
Right.
Let me just give you one example. So to build a 75 kilowatt battery cathode and all of the copper wiring for the electric vehicle, we would need to move 6,000 kilograms of nodules.
Right.
But if we were doing that same activity on land, we would have to move 64,000 kilograms
of material. Wow.
And the energy involved in doing that, the tailings that you create, the CO2 emissions, to build that one battery will generate more than 90% less CO2 emissions.
Right.
Now, that's a combination of the CO2 generated through activity and also the sequestered carbon that we will release on land. There is a lot of carbon stored at the bottom of the ocean, but it never gets untrapped. It's 4,000 meters. It's there. It will not. We will do nothing to release carbon, sequestered carbon into the atmosphere.
Yeah.
Whereas, of course, on land, you do. You're moving soil. You're building down trees, and of course, there's lots of papers that are coming out now saying, listen, these tree programs, they're good, but they're not the solution, because they don't deliver the same carbon traps that are there today.
Right.
Because it takes, after 60 years of replanting a tree, plant a tree, come back in 60 years' time, it's only 40% as efficient as it was before you ripped it down.
Right.
So
it's a very slow process.
It's a very slow process.
Yeah. Okay, so these things are on the seabed, up to 4. So, I mean, are they generally? Oh, okay. I'm going to backtrack now. The ocean is big. I had a look at an atlas this morning. Kind of just a photograph of the world.
Yes.
And you go, oh my God, the ocean is the vast majority of the planet is ocean. That's without question. Yep. But so there's a lot of it, and that's what's hard to imagine, because I think when you, as landlubbers, which I'm definitely one, I go to the coast and I see the sea and I go, I know France is just over there, or Ireland's just over there. It's not that big. And you think, oh, actually, America is quite a long way away. There's a lot of sea between here and there.
Yes.
I think we haven't got, unless you've been out on a boat for a long time, you don't really have an impression of quite the scale of it. Mm-hmm. So there's huge areas then.
And if you think about the Pacific Ocean, if you fly from Los Angeles to Sydney,
which I've done, I'm sad to say, many times. Yeah.
Well, as you know, it's like 15 hours and you're over water the whole time.
The whole time. Yeah.
It's amazing.
Yeah.
Well, the ocean is 360 million square kilometers, thereabouts. Right. 361. And we will be able to build 1 billion batteries off around 508,000 square kilometers.
Right.
Yeah. So 500,000 kilometers over 360 million square kilometers.
Right.
So it's
quite a small percentage.
It's quite a small percentage. And thank Mother Nature that it's all compacted into one little area.
Right.
And so, and this is what, it's, if Mother Nature ever had to put an abundant resource that just happened to have all of the battery metals we need to build these batteries, 4,000 meters below sea, more than 1,000 miles from the nearest land, would seem to be a pretty good place to put it.
Yes.
I think.
Because I suppose, and is that part of the reason it's become possible is that also the technology. So you can send down a remote. I'm from memory. I remember seeing the idea of a remote control scuba tank underwater doobery.
Yeah.
I don't know what you call it. That collects these things. Yeah.
A scuba doobery.
Can you paint that on the side? Underwater scraping doobery.
But that's where, so I didn't finish my earlier story. In the 1970s, they started to collect these nodules. Right. And so they built the know-how. And there were 4 different consortia that were working, and they were very successful. We have all of the amazing documentaries that were made at the time. But what they hadn't figured out was who owned the ocean.
Right.
And so it was the United Nations that stopped the development of the industry in the 70s, because America had come forward and said, we want to claim part of the Pacific Ocean. And of course, all the ambassadors went, no, that doesn't sound too equitable. And so the law of the sea was finally agreed in 1982.
Right.
And that's what the United Nations Convention of the Law of the Sea is, what gives certainty around who owns what. Right. And so they then set up the International Seabed Authority to govern the high seas.
Yeah. Because, if you're 1,000 miles off land, you're not on anyone's coastal protected area. I mean, you're right out in the middle of
Exactly. Yeah, the rough rule of thumb is that a sovereign owns everything within 12 miles
of their coast, right?
Of their coast. Yeah. They have an economic right to everything within 200 miles.
Right.
But beyond that, it's not yours.
Yeah.
It's everyone's. Right. It's the common heritage of mankind.
Yeah. And so there is then, just so that I understand that, a pretty specific area where you find these. I mean, for instance, in areas in the middle of the Atlantic, you're not going to find them. Is that correct?
No,
right.
That's right. Yeah. And even if you did find them, let's say they're not known to be in the Atlantic, but let's say in the Peru Basin or the North Sea where they have been found, they're just not worth recovering.
Right.
Because they don't contain the nickel and the copper.
Right. And is that the majority? So that nodule you held up is the majority of the material in that nickel and copper. Is that what is mostly in it?
By value, it's about 50% nickel.
Right.
By value, it's about 50% nickel. And so it kind of goes nickel, and then copper, cobalt, and manganese come in sort of roughly equal second. Yep.
Wow, that is extraordinary. So there is, because that's at the moment, the kind of morally contentious material is cobalt.
Yes.
And clearly there are battery designs that are coming through that would use very little of it.
Yeah.
Or totally. Virtually none, but which is really good. But the fact that there is a source of cobalt that's outside the Democratic Republic of the Congo is quite encouraging, because it is very difficult.
And we've seen some of the car companies do deals with, let's say, Glencore, because they're a major provider of cobalt out of the Congo. I think 90% of every ton of cobalt ends up in China.
Right.
But Glencore themselves control about 40% of that. And so, and I saw a deal recently where Tesla had agreed a deal to buy Glencore's cobalt. But of course, the cobalt market is growing. It's allowing for the fact that they're going to design batteries with less and less cobalt. But even with allowing for that,
but they're making more batteries.
That's right. The demand is that market is going to be 3 times bigger. And so while Tesla might get the nice cobalt from Glencore, the other customers are still kids are still going to be going down mine shafts. 6-year-olds are still going to be going to work every day for nothing.
Yeah.
And and that's a problem for consumer-facing brands. And this is the other challenge, right? We sometimes have the minority group, some of the NGOs who are saying, no, we shouldn't do this because we should just consume less, right? Or we should just recycle more. We are adamant about the future is absolutely recycling, and batteries are very, very recyclable. So we're counting on that.
Yeah.
But it's very easy when you're sat, in your lovely home with running water, with electricity, with all the things we take for granted, and then to say the developing world can have that,
consume less.
Come on.
Yeah, you people who have consumed virtually nothing in comparison to us in the last 250 years, can you stop and consume less? No, it doesn't really wash, does it? I mean, it is.
It doesn't.
And it is that thing where, and it happens, I'm very party to it all the time, is people saying, one, it's all right for you. And this is coming from someone who lives in a developed Western country with mains electricity, clean water, a sewage system, a public transportation system, and a health system, and they're telling me, who might in circumstances be fractionally more wealthy, oh, it's all right for you, but I'm really suffering. No, you're not. Shut up.
Yeah, exactly.
Shut up and go and work for an NGO in the Congo and don't talk to me for 20 years and then come back and make me feel guilty. And I will feel guilty then, because I haven't done that.
Exactly.
No, it is all very. But I mean, and that's, I think, the key thing for this. It's the relativity of it, isn't it? It is that thing where people go, oh no, it would be terrible if people scour the ocean. Because it's like, if you use that sort of language, they're going to go out there and scour the ocean. Well,
no, that's right.
Not been to, I am lucky because of the quirky TV work I've done, is to go into massive mines in huge trucks and operate the biggest digger in the world. And you go, this is making an impact. This is some big stuff going on here, I mean, and going to large power stations and oil refineries, just because of, I did that show for years about how things work and how things are made. You kind of learn a lot more than as a general member of the public. You know, you sort of see into places.
Absolutely. Yeah. Which by the way, I love that show. And so even worse than what you've seen when you were making your show is what's happening in some of the developing countries like Indonesia, which is the #1 nickel producing country. And their nickel assets tend to be something called nickel laterites. They form through wet leaching. So, you know, wet trees, rainforests, spread over long, very thin layers over very large areas. And the devastation that's going on in that country right now is horrible. And
so to extract the nickel, they're basically stripping the land and the the forests to get to it. Wow.
Yeah. And tipping the tailings into the ocean.
Right.
You know, and so it's heartbreaking. And so, it's about, there's some tough grown-up conversations to be had and some decisions to be made. And so, you know, unfortunately, people often come to the table with a heavy bias. And, you know, I'm not saying most people, I'm just saying some people. And thankfully, most people, you know, get very, very excited about what we're doing. But, you know, we have to deal with the people that aren't as well.
So in terms of the kind of technology you need to successfully commercially extract the nodules, I mean, presumably, because the amazing video, which I will post links to, it is great, of what you've been doing. It's really fascinating. But presumably that is on quite a small scale. I mean, if you were doing this on a kind of commercially industrial process, you're going to have quite a big ship with some quite big sort of diggers, underwater diggers.
Yeah.
I mean, that must be. And have you got to that stage yet, or are you working
well,
on it?
I think what you were referring to was part of our exploration program.
Right.
So that's how we define the resource and do our biological surveys and study the organisms and so on. And then we are building right now our pilot harvesting system. And so that will be a tracked vehicle. So it will move along the ocean floor. It will collect nodules. It will take advantage of some fabulous technology that we all, you know, if you've flown in a plane, you depend on the Coanda effect that basically allows us to remove the nodules from the ocean floor with the minimal impact possible.
Right.
And so, but the honest answer is we do not fully know what the most effective way of getting the nodules will be. We think it's a tracked vehicle, and we're developing that with one of our shareholders, a company called Allseas. And Allseas are one of the largest pipeline companies in the world in the deep ocean for oil and gas. And they have 600 engineers, and the best of that team are now working on this project.
Right.
And so, you know, we just figured, while we have designed our system, putting it into production is a different job. And so we're doing that with our partner Allseas, but we're also working up some other ideas with some other companies. And, you know, I think we'll see an enormous amount of innovation in the offshore space when it comes to solving this challenge. And from our perspective, we own a lot of these nodules. We have defined already about 1.6 billion tons of them. Wow. So our job is, you know, to continue to explore what's the best way to recover them, both economically and environmentally, and then encourage people to continue to innovate to get to the optimal solution.
Because it's got, I mean, it is just mind-boggling for a landlubber. You know, the idea of just lifting one nodule from 4,000 meters below the sea surface to the top. You know, I just think that's a very long bit of string. That's a lot.
It is. It is.
You know, all that stuff. And I'm sure but I think this is what I find exciting about, in fact, the whole area of renewable energy, sustainable technology, you know, battery technology, solar, wind, all that stuff. Every time I meet the grid, how the grid operates, every time I meet an actual engineer who's actually working on that stuff, they're having a brilliant time. You know, because you go, oh, all these electric cars, they might melt the grid. Oh, brilliant. You know, no, they won't melt the grid, but this is really exciting. And this is a great challenge of integrating renewables into a grid system that was designed to burn coal, essentially. You know, that's like, oh my God, how are you going to do that? And that's a fantastic challenge. And it's in some similar ways to this, and in similar ways to the offshore wind, is the people, the actual engineers and technicians that are installing offshore wind worked in the oil and gas industry, because they've been putting big things in the sea for the last 50 years that don't fall over. They know how to do that. And for you to have a company that's laid gas pipes on the seabed and has gone, you imagine the development they've done in that last where they would have put a gas pipe down and going, oh, it's got a leak, or it's broken, or it's fallen in half, and how do we fix it? You know, to learn all those processes they've been through.
Oh, totally.
It's such an advantage in a way to use that now.
That's right. And so the demise of the oil and gas sector, or the services sector, has been a massive win for us, because those companies know they have to get into a new business. And, you know, in the case of Allseas, they have a fleet of these very large pipeline vessels that can be converted into collectors for us. And so they're saying, well, we know in 10 years' time, we will not be doing this anymore. Yeah. So we need to diversify now. And we're very fortunate to have them as one example. Maersk is another one. Maersk is one of our shareholders.
Ah, right. Okay. I've heard of Maersk. Yeah.
Yeah. And so, but Allseas, interesting company. You know, they're owned by one man, engineering led. He's an engineer, you know, loves an engineering challenge. Right. And so there's a lot of excitement amongst engineers of all varieties on this project. Yeah.
Well, also, I mean, you know, it's a thing, you know, hopefully in the not too distant future, we can come and film with you, you know, but certainly the actual vehicle that will be on the seabed, the tracked vehicle, is not going to have a diesel engine in it, I'm guessing.
It will not. No, it will
so
not.
It will effectively be an electric vehicle, I would assume.
It will. Yes.
Electric drive. So that is fascinating in itself. So to be able to see that is the most extreme electric vehicle that we might ever. I would, if it's on the dock somewhere and we can find a way of getting to it and filming it, I'd love to do that.
Sure.
It's fascinating. But I mean, so that, you know, it is that side of it I find really intriguing is, you know, if you've got a scoopy thing that scoops up the nodules, then how do you get them to the surface? Is that in literally a bucket and a winch? Is it that thing, or do you vacuum pump them up, or is there a system?
Both, actually. Yeah, there are. But once again, there are two schools of thought. One school of thought is that the way to get them up is through what's called an air riser, and that's what they did in the 70s. So they put down these big pipes, connected them all together, injected compressed air at about a third of the way down, and the compressed air expands, creates a vacuum, and up it comes. Right. But the other way might be a basket. And so once again, we don't know. But our first system, which we'll have in the water, it was going to be Q3 next year, but COVID has caused us about a 6-month delay. But it will be running a tracked vehicle. It will be using an air riser to lift the nodules back to our production vessel. So,
Wow, that is extraordinary. So and that sort of thing, then once you've got it all set up and it's running, can kind of run 24 hours a day. I mean, you know, if you're connected, it's just moving all across the seabed at a slow pace, sending all this stuff up. That's extraordinary. Yeah. Wow.
And that's the other wonderful thing about capital efficiency, because, you know, terrestrial resources are stationary, and they tend to be, they don't come to you. You've got to go to them. Yeah. And you've got to, you know, build power and water and roads and railway lines and deep water ports and put a workforce there. And obviously they're 3D resources, whereas we're more 2D. You know, our nodules just sit on the ocean floor, but it means that our capital is all mobile. You know, we construct it wherever it makes most sense to do so. And then we float it on out there. And it means that, you know, that's one of the problems for terrestrial deposits. They tend to get hemmed in because of infrastructure. Right. Whereas obviously what we can do is we collect the nodules onto our production vessel, and then we can ship them to Asia. We can ship them up to Norway, where there's an abundance of renewable power and it's great for our processing, or we can ship them to North America. Right. So we have flexibility. We can ship it everywhere. Yeah. And that's our plan. Our plan is to have processing facilities in a variety of jurisdictions around the world.
Right. And so then at the present, we're going back a bit now, so I'm trying to remember the situation, but you're waiting for, as you call it, the code. So the legal ability to do it. I mean, I don't know what the I don't know how you would judge that, but what the chances are of you getting that permission. I mean, is it looking quite positive at the moment?
It is, yes.
Right.
Yeah, yeah. Sufficient enough for us to be spending hundreds of millions of dollars.
Right.
Yeah.
Yes.
Yes. So I really hope it works out.
Yes. Those are some seriously big fingers you need to cross.
Yes, yeah, absolutely.
But I mean,
yeah.
it kind of, there's such a weight of pressure, because I think that is the thing we're experiencing now, is the development of battery technology, the generalized kind of global understanding that if we can store seriously large amounts of electrical power around the world, that really does make a difference. And it's totally. When you see the early development of that, and I think there'll be, historic. I think people will be going to South Australia in 150 years' time to go and look at the first grid battery. This was considered enormous. It's 200. What is it? It's 127 megawatt hours, I think, that battery. Yeah. And by then, there will be batteries that are 1 trillion megawatt hours. They are kind of, and half the size, a quarter the size, all that stuff. But that side of stuff is a fascinating thing to be. I mean, I'm really privileged to be part of it, because I have batteries in my house, and I just know. I don't have to believe or think theoretically or wonder. I actually know that we spend less on electricity because I've got batteries, and we run electric cars as well. When you can actually experience that firsthand, it's a very different argument. And you go, if you can then scale that up and go, if everyone had batteries in their house, small ones, not massive, they don't have to be big, but the massive impact that would have on our grid and on the way we generate electricity and what we import, it's off the scale. So what you're supplying is clearly vitally important. I suppose my only anxiety for you, and I think it's a low one, in all honesty, is the development of alternate materials that are being used in batteries. So carbon on carbon batteries exist now in laboratories, and they don't need any of the materials that you're talking about. And I think you're safe for a few years.
Look, I'm counting on the fact that there will be, because we're doing this for all the right reasons.
Yeah.
We're doing this to have a positive impact on the planet. And if battery technology arrives that makes the need for our metals redundant, fantastic.
Yeah.
Because the planet will be the winner. And so, but the way I see it, that the auto manufacturers have laid down many tens of billions of dollars in battery technology already, and it's taken the cost out of those megawatt hours, and so, or kilowatt hours, and such that they're more and more affordable, and those costs will continue to decline. And so I think for the next 10 or 15 years, it will be the answer. And I hope by then we have some alternatives. But I also think that the demand that we talk about in our white paper is only one tiny part of the market. We're only talking about electric vehicles, and we're only talking about 1 billion of them. We're not talking about heavy transportation. We're not talking about grid storage, home
shipping,
storage, shipping, everything. And so we need these other technologies to come along as well. And so I think if we just depended on NMC batteries, then that's a challenge.
And I mean, that's actually one thing that is, because I'm just thinking often when I do these interviews or podcasts that I will later see in the comments the question I should have asked. So I'm always trying to channel the clever people that listen to our shows and watch our shows. But it's a comparative cost. So you've got a mine in, I don't know, like Chile with a massive digger and a load of trucks and train linked to a processing plant with tailings ponds. You can break down the cost of a kilogram of the final material. How does that compare with when you do the same thing? You extract that, it goes on shore, it's processed, and you've got a kilogram of that material. Is it an economic?
Yes.
It's clearly an environmental advantage, but is it an economically viable?
Absolutely. Yeah, we will be we will be one of the 2 cheapest producers of those materials on the planet.
Right.
And so, it's in the mining world, it's known as a C1 cost curve, and it's basically the cost of mining, or in our case, collecting, of transportation, of processing to produce that finished material.
Right.
And so when we take into account all of those costs, we come in the bottom quartile, but
Right.
actually will be the second cheapest producer of those metals. And the reason for that is goes back to the massive material we don't have to move.
Right.
The
Yes.
example I gave you of 6,000 versus 64,000.
Yeah.
And the very high grade. So this nodule that I hold in my hand,
Yeah.
we use 100% of it. So no tailings, which means
Right.
100% of this we are able to sell.
Wow.
Whereas if this was a piece of copper-bearing ore from Chile, then at best 1% of it would be usable. The other
Wow.
99%
It's just
would be
waste material
waste.
that you've
Yeah.
got to put somewhere. Yeah.
And so that filters through to the economics, obviously.
Yeah.
So,
That is absolutely extraordinary. How? Because I mean, I understand I've seen that process, the quarrying metal, and you think, well, that doesn't look like copper to me. It looks like rock, and then you realize, yeah, because it is rock. 99% of it, there's a tiny bit of copper in there. It is a hard thing to understand when it's not like if you find gold nuggets in a stream.
Yeah.
You're basically digging up a mountain and finding a nugget of gold, aren't you? I mean,
that's right.
What I'm hoping is that within the next 18 months or so, before you actually sail off on a massive ship with your tracked extractor, I just want to come and see. I mean, where are you developing that machinery?
In Delft, and
right. Oh, fantastic.
So you consider yourself invited. I'd be delighted.
I'd love to come and see it.
Yeah,
and I'm fascinated in. Oh, sorry, no, you carry on about Delft. Sorry.
No, I was. That's the beauty of having such an engineering-led partner as Allseed. They have massive research and development facilities.
Right.
We've been testing everything in their own facilities, and Delft University is also, the leading authority on seafloor surfaces. And so, it's the place, because obviously, Holland has had a desperate need for these services over its history, being such a low-lying nation. So.
I was just going to say though, what your background is, because it's clearly a great passion of yours. I mean, and your understanding of geology is impressive, because I can sort of tell the difference between marble and sandstone. That's about as far as I could go.
Yeah. Well, for those people who do understand geology listening to this, I know nothing.
Oh, right.
But I'm a very curious person, and I grew up in Australia. I started my first company at university,
right,
and I've been lucky enough to be building companies my entire life. And originally, I got involved with this industry of ocean resources back in 2001, but as an investor.
Right.
And that all worked out pretty well, but it taught me about nodules. It taught
Right.
me about this big, abundant resource. And so originally, I was busy on one of my other projects. And so I helped finance the establishment of the company. And then I eventually became the largest shareholder. And it was like, look, I think it's time to get involved in this, get very hands-on, because we had hired someone out of the resources sector to run it. And as I started spending more time, I realized, firstly, the impact. Sometimes we don't stop to think about, the world, climate change, the data behind it, what the supply chain looked at, what the LCA impacts could be if we don't change things. And so as I garnered more and more information, I realized how impactful this project could be to the planet, and also that it needed a stubborn, tenacious entrepreneurial type to give it a chance
drive
of
it
success.
through.
Yeah, and I consider myself absolutely, a citizen of the planet. I'm not an ocean guy. I'm not a forest guy. I'm a planet guy, and I care about it. I care about what direction it's heading and what shape it's going to be in generations in the future. And so I reorganized the team, and I took over as chairman CEO a few years ago, and it's been it is a life passion.
Yes,
it has become my life passion.
Yeah, I mean, that's what is obvious. And I think also, again, it is a very clear, it feels like a clear gear change, because I think 50 years ago, with your same entrepreneurial spirit, you could have invested in, I don't know, what, Formula One promotion or aircraft manufacturing or something, without really any, going, wow, this would be glamorous and fabulous. And there's more, I'm meeting more and more people and come across more and more people who could do that, could operate in any area in the commercial world and go, well, hang on a minute, that does mean, there's no other polite way of putting it, we're shitting on a lot of people and the planet by doing what we're doing. And totally. It is that change of attitude where, and also to see the opportunities. It isn't like, oh, I'm going to sacrifice everything and live a really, poor life by not doing all those things, because I definitely went through that as a young hippie teenager, that I was basically wanting to live in a hobbit hovel and consume nothing as to, because of the impact on the world I was having. And then you eventually go, quite like to have a bath. The hobbit thing's great. I love it, but can I just have a quick flannel wash, because it's all getting a bit grubby, and I think I remember that I was with a hippie friend, sort of living out in the wilds, and I went, do you know what, dentists are really good. Because I had a toothache. I don't want to go to a medieval dentist. I don't want to rub some herbs into my gums. I want to go to a dentist. It's that stuff that, there is a brilliant way of using the new technologies we've got in a way that is conscious, that goes, well, if we burn that fuel, we can't burn it again. I think that's the bottom line. So, that's the thing about you, and I absolutely agree with you about the dangers of the extraction process. But generally speaking, you extract that copper, you've got copper, this is from a mine in Peru or wherever. You've got that copper, you make something with it, 25 years later, you tear it to bits and you use that copper again. You can't do that with diesel, with gas, with fossil fuels. You use it, you extract it with enormous environmental impact.
Yeah, exactly. And that's why we think about this as atoms as a service. We think about not selling these, but letting you use them, and when you're finished, give them back, and we'll recycle them, and you can have them again.
Right.
And so, and I think that's where the mining industry needs to change the way it thinks as well. It should be, because eventually we've got to stop extracting. Right?
Yes, it's good. We've got to stop it.
Yes. Like I tell my stakeholders, we want to be out of this in 50 years, over.
Right.
Because we have to be moving towards closing the loop.
Yeah.
And the terrestrial mining guys should be doing the same.
Yeah.
Like they're worried about, they're selling this material. They shouldn't be. They should be renting it out.
Yes. That's an interesting way of looking at it. It's a very different attitude, isn't it? Because that is that, drill and burn. It is, there's only one route that only goes one way. You drill, you extract, you burn, finish, that's end of. And I think that is the critically important difference that we have to make that next step. And I think, I'm very, very impressed with what you're doing. I think it is absolutely extraordinary. And I really wish you the best with it. And I'll keep a close eye. And hopefully we can come to Delft.
Yes.
I mean, any excuse, basically at the moment, any excuse to go to the Netherlands.
Yes, or anywhere.
Really hope you enjoyed that. It was a fascinating conversation. It was just brilliant to talk to Gerard. I really love what they're doing. If you want to find out more, it's really worth going to, if you just Google DeepGreen, you're going to find their website. It's at I'm now, literally, as I speak, double checking what the actual web address is. Let me double check. Well, I really hope you enjoyed that. It was a most fascinating discussion to have, and it really epitomized what I try and do on podcasts and usually fail. I did fail today in some ways, but it's to not know too much before I start to talk to people, so that they tell me stuff, so I learn as we go along. And it really was, for me, it was like that. I know I waffled on and went off on tangents every now and then. Sorry about that. I'll try not to do it. Just in case you want to find out more about what Gerard is doing, you just go to deep.green. That's their web address. What a cool web address. The company's called Deep. So if you just Google DeepGreen, you'll find it. and amazing videos they've got there of how they have started doing their research and their biological impact and what they're doing and all that stuff. Really fascinating. Anyway, that's all. Obviously, please do subscribe to this podcast. We have some really brilliant people coming on the show in the next few months. It's going from strength to strength. Obviously, if you haven't seen the Fully Charged show on YouTube, I would suggest that you might enjoy it. You might want to subscribe to that too. You might want to help support us on Patreon or YouTube memberships. Don't want to put anything that even resembles emotional pressure on you for doing that. I'm just laying it down there. All the links are in the show notes to this episode. You can go and have a look at our webpage, which is a very, very comprehensive overview of renewable energy and future transport systems at fullycharged.show. Not quite as super cool as deep.green. I mean, that is like proper clever. But we're fullycharged.show. That is really good. And that's it. As always, if you have been, thank you for listening.